Hello maths fans, and we're back with some help with clip 184, proofs using circle theorems. And in this instance, as with all circle theorem questions, you need to make sure you know your circle theorems word for word, and so you can use them to make your proofs. Read the questions very carefully. QP and S, sorry, I meant to say question 5, this is. QP and S are points on a circle. RST is a tangent C. Straight away I'm thinking about the tangent theorems that we know. Okay, so there's the alternate segment theorem, which looks like could be there. We've got a chord and we've got a tangent, so that 46 degrees there by alternate segment theorem would be the same as any angle drawn off that chord in the other segment. Okay, well, there's the chord. That's the minor segment. The major segment's over here, so we go Q to the circumference and back to S. That's going to make that 46 degrees. Okay, so what do you think about that? Angle between a tangent and radius is 90 degrees. Maybe we can use that, I don't know. And the other one is external angles, lengths of tangents from an external point are equal. So there's not two tangents, so it doesn't look like it's going to be that to me. Okay, I can't quite get the T on there. Let's have a look. Okay, so RST is tangent. Circle C2 passes through the centre O, S and Q. So C2 is O, S and Q. So what they're saying is there is another circle here. Oh no, it's there. O, S and Q. There we are. Prove that SQ is not a diameter of a circle C2. Now I know it doesn't look like it's a diameter from where it's drawn, but we can't go on it looking. These diagrams are not drawn perfectly accurately. So let's have a look at what we found out. I'm going to put that information that we've already used there. So I'm going to say the QPS is equal to 46 degrees, and I'm going to call that the alternate segment theorem. Okay, let's go back here. SQ is not a diameter. What do we think if SQ was a diameter? Let's look at it that way. For it to be a diameter, that would mean that if I just draw this on here a minute, that angle there, if SQ is a diameter, that would have to be 90 degrees, wouldn't it? Angle in a semicircle is 90 degrees if SQ was a diameter. So really this angle here is going to be the make or break of my proof, I think. Now, can you see what that angle might be? So go back to circle C1. You've got an angle at the circumference, SPQ, and you've got an angle at the centre, QOS, and they are, aren't they? Okay, so look, QOS, if you look at that, the arms of QOS are here and here. So any angle now drawn from S and ending up at Q that bounces off the circumference is going to be half that one there, which means that must be double. This angle here must be double this one here. So we'd say that QOS equals 92 degrees. Angle at the centre is twice the angle at the circumference. And again, remember what I said about this. Wording is very, very important here. Any sloppiness in the wording, you won't get the marks. Okay, so I said that's 92 degrees. Now remember what I said a minute ago. For QS to be a diameter, that means that QOS would have to be 90 degrees. Okay, so what we're going to say then, as QOS is not equal to 90 degrees, then QS cannot be a diameter of a circle C2. And if I really want to go a bit further on that, I could say because angle in a semicircle is equal to 90 degrees. It has to be equal to 90 degrees. And hopefully that's enough there to see that proof. I mean, it may not be the only way of doing it, find this angle, but looking at that at the moment, that looks like one of the easiest ways to do that. I mean, I'm just looking at it now, actually. If you look at OS, there is another way. OST would be 90 degrees. How could I find that 92 degrees, in other words? If all of that's 92 degrees, this angle here would have to be, 44 and 44. It's 88, which still means you can work out that to be 92. So there's more than one way of getting there. But I think the alternate segment seems to be the quickest. Okay, I hope that's useful, and I'll see you soon.